So question 1 is all about a particle that's being held in equilibrium, and there are a few forces that we can add to this. We don't have the weight on here currently, so let's just add that on vertically, W, and we also need the tension in the string, which is going to be here, T. And while I'm at it, I'm just going to compose this into its horizontal and vertical components. Bearing in mind that obviously if this angle in here is 25, then the angle down here is going to be 65, which is going to allow me to write this as T sine 65 and my other angle as T cos 65. Now let's look on to the rest of the question. What we actually asked to do here, we need to, first of all, in part A, find the tension in the string. Okay, so the only way I'm going to be able to find tension currently is by resolving horizontally, because that's the direction in which I only have one unknown. If I try and resolve vertically, I've got a situation where there are two unknowns, so we're going to resolve horizontal. Now if I take all my forces acting towards the right, which is T cos 65, and subtract my forces acting to the left, which is 5, I'm going to get 0 because there's no acceleration, it's a static system, which tells me that T cos 65 will be equal to 5, or that T is equal to 5 over cosine 65. And if I tap that into a calculator, I can quickly find out that the answer here is 11.8 newtons. Moving on to part B of this question, unsurprisingly I've resolved horizontally. I now want to find the weight, so what am I left to do now is to resolve vertically. So thinking about all the forces acting up, which is T sine 65, subtract all the forces that are acting down, which is W, and that's again going to give me nothing. I'm going to use my exact value from part A for this question, so instead of T I'm using 5 over cosine 65. Multiply that by sine 65 and rearranging at the same time, that can be set equal to W. Now I can throw this into my calculator at this point, or if I'm sneaky I spot that this is tan 65 in disguise, and 5 tan 65 tells me that W is equal to 10.7 newtons.